Okay, so welcome back. Today we have a challenge for you, and I really encourage you to think about this challenge, see if you can find a solution on your own. We're not going to present the solution in this video. The goal here is to have you consider how you would solve this problem. And if you think you're a skilled software developer, I think this challenge will help you to understand what it really means to be skilled, unlike what a lot of newbies and novices seem to think. So the goal here is to point out a very, very common misunderstanding between newbies and novices where they think that, for example, hey, I know how to write code in a certain programming language, therefore I'm an expert software developer. And as you'll see as you get more experience in the real world, that is often a very huge mistake. And the reason why it's a big mistake is it's a bit like saying, okay, I know how hammers work. I know how to hammer nails. And in fact, I have experience hammering nails. And in fact, I also know how screwdrivers work. And I can screw screws. And I know how that all works. Therefore, I can design and build a house because I know how the tools work. And that you will see very, very often in the science, engineering, software development world where people think it's all about the tools. And what's even worse, now we live in an age where when it comes to software development, most people are of the attitude that, hey, all I need to do is download or copy and paste somebody else's software and I'm done and I'm an excellent software developer. And that actually gives you much less value as a developer or a technical person because, any 6-year-old can copy and paste somebody else's code. So you're getting less and less valuable the more you focus totally on the tools, and especially the more you focus on using other people's code and not developing it yourself. And hopefully this challenge will show you that the real value in a software developer or engineer or scientist is being able to understand how to solve problems, not how to use tools. So what is the challenge we're talking about? So as you can see here, we've got some input data. Our scenario is that maybe your boss has said, hey, here is some input data. So as you can see, it's some groups of pairs of numbers. And the boss says, hey, I want you to take these pairs of numbers and I want you to convert them into this diagram here. So that's the challenge, to try and figure out how you can do that. So what does this all mean? Well, these pairs of numbers define what you see here in this diagram. Now, first of all, what I want to do is I want to give us a definition of what we're talking about and some terminology. These vertical lines with the numbers are we're going to call them buses. You can call them whatever you want. I'm going to call them buses. So I've got bus number 1, bus number 2, 3, 4, and 5. Now these horizontal lines, I'm going to call them lines. You can see we've got a line between bus 1 and bus 2, one between 2 and 3, and so on. So what this input data describes is the lines between the buses. So for example, we're saying there is a line between bus 1 and 2 which says, hey, I need to have a drawing with a bus 1, a bus 2, and a line between them. The next one says there is a line between bus 1 and bus 5. So your software needs to make sure bus 1 is drawn, bus 5 is drawn, and that there's a horizontal line between them. And so on. You go down the list and you've got between 2 and 3, 3 and 4, 3 and 5, and 4 and 5. So that is the goal of our application. We want to take this input data and somehow come up with an algorithm that ultimately we can put into software that will take this data and draw this diagram. Now, the first thing we have to do is figure out what are the rules that we have to follow in this algorithm. Well, as we said, the buses are vertical lines. The lines are horizontal lines. We also don't want any lines to cross over any buses. So for example, this line between 1 and 2 and this line between 2 and 3, you could also imagine how this is actually just one line that's not connected to 2. It's just going between 1 and 3. We don't want that because that's confusing. It makes you think that this is 2 lines when maybe you intended that it's only 1 line. So we want to make sure that no lines cross over buses. They connect to the bus and that's it, which kind of defines how you're going to have to lay this out. so that if there was a line between 1 and 3, you're going to have to move it around so that it doesn't cross over a bus. The next rule is the algorithm must work on any input data. Here we've got basically 6 lines and 5 buses, but we want this algorithm to take the data, it could be 30 lines and 20 buses. We want to use the exact same algorithm on any input data. So that's going to be a challenge. Now, also, the buses don't have to be numerical from left to right. Here we've shown from left to right, 1, 2, 3, 4, and 5. We don't have to have that. So that might make it a little bit easier, but just keep that in mind. And the other one is it's got to look nice. All right. So what do we mean by look nice? Well, that's kind of nebulous, but artistically it has to look good and has to be easy to view. So that's another part of our design that we're going to have to consider, and you may have different ideas on how to apply that. Now let's just take a variation of this to see what we're up against. So let's say our input data included everything we had except the line between 1 and 2 didn't exist in the input data. So it might end up looking like this, where there is no line between 1 and 2, but all the other lines and buses exist. Now you might say that doesn't really look nice. Maybe we can have our algorithm make it look a little bit different. And in fact, maybe we can have it like this. See, there is no line between bus 1 and 2, but all the other lines exist and it flows a little bit nicer. Again, that's kind of an artistic view and how you want to approach this. So the challenge is you need to determine what algorithm do you use to make this happen. So again, this is not about saying, well, I know what code I would use to draw lines in a bitmap, for example. This has nothing to do with that. This is about what algorithm could I use for any input set of data that will tell me where to draw those and how to lay out this diagram. That's what's important. Now again, I encourage you, think about this. Think about how you might come up with a solution. And again, ideally, it would be nice if you come up with a solution, leave comments below the video, or even better, make a YouTube video and show how it's done and leave a link to that video so we can see what your solution is. Anyway, I encourage you to give this a shot, see if you can figure out what the answer is. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.